Okay, this is our final review before our test, and so I want to go through and work these problems for you. To begin with, we have the natural log of the quantity 8 minus 2n is equal to the natural log of 4. Since this is the natural log of both, we can exponentiate each side, but what happens is our natural log cancels, and we have 8 minus 2n is equal to 4n. I'm going to add my 2n to both sides, and 8 is equal to 6n, divide by 6, and my fraction reduces to 4/3. And so there's my answer. Number 2. Again, I have my log base 2 and log base 2. Since they're the same on both sides, that means the other part must be equal to each other. So 5 minus 2x has to equal to 2x plus 5. Well, I'm going to add 2x to both sides to solve my equation. And I get 5 is equal to 4x plus 5. Again, my goal is to get the x by itself. So I'm going to subtract 5 from both sides. 4x equals 0, divide by 4, and I get that x equals 0. And so my solution is B. Alright. My next problem, problem number 3. For this problem, again, I see that the log base 13 is the same on both. So I have 3n is equal to 5n minus 4. Again, with n's on both sides, I want to get rid of one of them. So that negative 2n is equal to negative 4. Divide by negative 2. And n is 2. Number 4 is just a little bit different. Because of the negative 8 on the front, it's negative 8 times this. So I must do the opposite and divide by negative 8. Squeezing that in a little bit. So it cancels over here. So I have log of a minus 8 is equal to negative 1. Now my base here is a 10. Whenever my base is a 10 and I only have one logarithm, I'm going to rewrite it as an exponential. 10 to the negative 1 power is equal to a minus 8. Base to the power equals the number. 10 to the negative 1 is 0.1 is equal to a minus 8. So I'm going to add 8 to both sides. And I get 8.1 is my a. Now all of my answers, you'll notice, are in fractional form. So if I do that and change my fraction, I get that that's 81 over 10 is my a. Again, to change a decimal to a fraction, it's math, enter, enter. Just a moment, please. Sorry, I had to close my door. Alright, so now number 5. Again, I have the negative 2 in the front, so I need to divide both sides by the negative 2, because it's negative 2 times that logarithm. So that leaves me log base 8 of negative 9x is equal to 3. Again, since I only have the one logarithm, I'm going to take it out of logarithmic form and put it in exponential form. Base to the power equals the number. So 8 to the third is equal to negative 9x. Now let's pull the calculator up. Sorry. And I need 8 to the third power, 512 is equal to negative 9x. Divide by negative 9. Divide by negative 9. Okay, so negative 512 over 9. Number 6. This is addition, so I put this back together as multiplication. So log base 4. Now I need to multiply these two together. 2 times x, 2x. 2 times 6 is 12, and it equals the 3. Again, this is in logarithmic form, and I need to change it to exponential. So the base to the power equals the number. 4 to the third power is equal to 2x minus 12. 4 to the third is 64. Add 12. That gives me 76 is equal to 2x. Divide by 2. And x is 38. When I have two logarithms and there's a plus sign between them, it means I put it back together by multiplying. Multiply. Okay, you must multiply. So number 7, again, I have two logarithms separated with a plus sign, so I have to multiply. So I have log base 4, and I need to multiply these two together. 10 times x, 10x, 10 times 1, 10, and it equals log base 4 of 67. Now I have two logarithms, but they're on opposite sides of the equal sign, and if they're the same log and the same base, so that's good. This part kind of cancels each other out if I exponentiate, and so I have 10 to the x, 10x plus 10 equals 67. Subtract my 10, and I get that 10x is equal to 57, and divide by 10. So x equals 57 over 10, which is right there. Now, if it's a plus sign, I multiply. If it's a minus sign, then I have to divide. So it's log base 4, and I have to divide 7 divided by negative 5x. And it equals 1. Base to the power equals the number. So take it out of the logarithm and put it in exponential form. Okay, 4. I have a fraction on the right. Sorry, let me slide that up a little bit. You have a fraction on the right where my x is on the bottom. So I need a fraction on the left. 4 to the 1 is just 4. To make it a fraction, I put a 1 on the bottom. And it equals my 7 over negative 5x. Since I have two fractions, I'm going to use what I call cross products. Multiply. 4 times negative 5x is negative 20x is equal to 1 times 7, which is 7. Divide by the negative 20. And I get x equals negative 7/20. Right there. Question? Awesome. Let's flip over to the back. Again, I have two logarithms, both of them base 4 with a minus sign, which means divide. So I'm going to rewrite that as log base 4 of 5 over x minus 5 equals 2. Base to the power equals the number. So 4 squared is equal to 5 over x minus 5. Again, I have a fraction with a x on the bottom. So I'm going to make that 16 over 1 because 4 squared is 16. Put the 1 on bottom to make it a fraction is equal to 5 over x minus 5. Again, I'm going to use cross products to multiply that. 16 times x minus 5. I'm going to come over here to write that. 16 times x minus 5. That's going to give me 16x minus 80 is equal to, and then I multiply the other side. 5 times the 1, which is just 5. Now I need to solve this problem. To solve this problem, I have to add the 80 and then divide by the 16. So 16x is equal to 85 and divide by 16. And so I get 85 over 16. Right there. Okay, let's look at number 10. Number 10, there's actually multiple ways to do the problem. What I'm going to encourage you to do is to look at your powers chart. 16 is 4 squared. So 4 squared to the negative 2k. Well, when you have a power to a power, you multiply that, so that'll become 4 to the negative 4k. Now let's look at the other side, 64. If I look down my powers chart, I see that's 4 to the third power. So my bases are the same. That means my exponents have to be the same. Negative 4k equals 3. Divide by negative 4. And k equals negative 3/4. Okay, let's go to number 11. It's a little messy looking, isn't it? Okay, you'll notice that my bases are the same, so that means I set the powers equal. Negative x is equal to x plus 3. I'm going to subtract an x from both sides. It gives me negative 2x equals 3. Divide by negative 2. And x equals negative 3/2. Right there. Let's look at number 12. Again, this problem has a couple of ways to solve. The easiest is to look at my power charts and see if I can change 9 and 27. 9 is 3 to the second power. And that's raised to the negative 2n. Power to a power, I multiply those together. So that becomes 3 to the negative 4n. Now let's look at the other side, 27. 27 on my powers chart is 3 to the third to the negative n. Now remember, you're multiplying that, so that becomes 3 to the negative 3n. Now my bases are the same, so I have to set the exponents equal. Negative 4n equals negative 3n. Add 3n to both sides. Negative 1n equals 0. Divide by negative 1. And n is 0. N is 0. My last three problems, excuse me. I need to get rid of anything but the exponential parts. I've got to add 4 to both sides. So I get 20 to the negative 2p is equal to 22. Log both sides. Remember what Miss Coleman calls it. Log it and leapfrog the power to the front. So I have negative 2p times the log of 20 is equal to the log of 22. I need some room. Sorry. Let me add something right here. Then I can keep writing. There we go. So I'm going to divide both sides by the log of 20. This cancels. So I have negative 2p is equal to the log of 22 divided by the log of 20. So let's type that in. Log of 22, close my parenthesis, divided by the log of 20, close my parenthesis. Press enter. 1.0318. 1.0318. And now I have to divide this by negative 2. And p will equal negative 0.5159. Negative 0.5159. And if I look, I see that answer right there. Okay, now let's go to 14. Again, I probably should have used a piece of paper on some of those where I was getting a little too long. Makes it much easier. Alrighty. Again, I've got to keep the exponential part by itself. I'm going to subtract 9. So I have e to the 7a is equal to 90. Because this is E, I want to use a natural